In this lesson, we're going to be looking at function composition. So before we start talking about that, I want to remind you about function notation and how to evaluate functions. So function notation is here. We have y equals f of x. Y is the same thing as f of x. So the output is f of x. So the whole thing is the output. F is just the function rule or the name of the function. And then inside here, the x is the input. So that's what we're going to replace. So let's look at a few examples. I have 3 different levels here, and the first one is just number inputs. So it says, given the functions above, evaluate the following. This is called f of 3. F of 3 just means instead of writing x, I'm going to write 3. Well, this is f of x, so that ends up being 2 times 3 plus 1, which is 6 plus 1, which is 7. So my input was 3, my output is 7. So we could say that f of 3 is equal to 7. The x value is 3, the y value is 7. Let's look at g of negative 1. This time we're using a different name, g, so we have to make sure that we are looking at that function. Our input is negative 1, so everywhere I see an x, I'm going to replace it with negative 1. So this is negative 1 squared minus 4. Don't forget to do the order of operations when you're dealing with exponents, so I have to figure that out first. Negative 1 squared is positive 1, and then minus 4. 1 minus 4 gives me negative 3. So my input was negative 1, and my output is negative 3. So g of negative 1 is equal to negative 3. The last one for level 1 is h of 2. So for this one, I'm going to replace x with 2 because my input is 2. So everywhere I see an x, I'm replacing it with 2 for h. So we would say 2 to the second plus 5. Like I said earlier, we need to take care of those exponents before doing anything else. 2 squared gives me 4. 4 plus 5 gives me 9. So h of 2 is equal to 9. My input was 2. My output was 9. So now let's look at level 2. These are actually probably easier than level 1 because you don't have to do much, but I wanted to show you because a lot of students get confused when you have an input that is a variable. So what is f of x? Well, you could say that you're replacing x with x, but really nothing's happening. It's just 2x plus 1, right? So everywhere I saw an x, I just wrote an x. All right, let's look at g of y. This one might make a little more sense of what we're doing here. Instead of writing x, I need to write y. So g of y is y squared minus 4. Everywhere I saw x, I replaced it with y because that was the input value. This is it. I can't do anything else with that, right? Can't combine like terms or distribute or do anything else. That's it. Our answer is an expression, and that's okay. So let's look at h of z. That's the last one here. H of z, everywhere I see an x, my input is replacing, I'm replacing my input with z. So this is going to be 2 to the z plus 5. And again, that's all we can do. I can't simplify that any further. So now the last one here is level 3, and this is where students generally get confused. So if you need to watch this over and over again, that's okay. What we're doing here is replacing x with an expression. So instead of writing x for level 1, I wrote 3, right? Now I'm going to write this entire expression. So I'm going to rewrite f of x down here so I can kind of zoom in. F of x is 2x plus 1. So f of x equals 2x plus 1, right? Everywhere I see an x, I'm replacing it with 5x minus 1. So this is going to be 2 parentheses 5x minus 1 plus 1. Notice that this x just changed to 5x minus 1. That's all I've done. Now, in this case, I can distribute and combine like terms and simplify this expression. I'm going to distribute. That's going to give me 10x minus 2 plus 1. Combine my like terms. So my final answer is 10x minus 1. Let's look at g. Remember that g of x, and we can see this up at the top, g of x was x squared minus 4. So x squared minus 4. What I'm going to do here is replace this x, because this is my input, right, with y plus 3. So this says x, I need it to say y plus 3. Squared minus 4. Now I need to simplify. Remember that y plus 3 squared, that's the same as saying y plus 3 times y plus 3. That's a binomial squared. And then I'm going to distribute. Y times y is y squared. Y times 3 is 3y. 3 times y is 3y. And 3 times 3 is 9. Then I just bring down that negative 4. I'm looking to combine any like terms. So the y squared didn't have anybody to combine with, but these 3y's can come together. 3y plus 3y gives me 6y. And then lastly, I have my constants. 9 minus 4 gives me 5. So this trinomial is my final answer. That is g of y plus 3. Again, all I did was replace the input with my new input, and that was an expression this time. All right, let's look at the last one. Recall that h of x was 2 to the x plus 5. So what I'm going to do now is everywhere I see an x, I'm replacing it with 2z, because my input is now 2z. So it's going to be 2. This is an x, so instead of writing x, I need to write 2z plus 5. We could go ahead and figure out, like, this is 2 to the second, right? 2 squared. And then to the z plus 5. 2 squared is 4, so this is 4 to the z plus 5. Now at this point, I can't do anything else, so this is the most simplified version.